All right, we are starting a new chapter, chapter 12. And in section 12.1, we get to define and use sequences and series. Sequences are values where we discover that there's a certain pattern to each of the values, where the function of the domain has, using consecutive integers or some type of pattern with the domain and range being the same thing. Series is similar to sequences, but instead of leaving the values as is, you get to add up all the values to create what is called the one sum, whatever that sum may be. So first off, we're going to look at sequences, and then we'll jump into series. Okay, so first off, being able to identify a pattern for a sequence. So for like examples A and B, for A, I have A sub n equals 5n minus 1, and then B is f of n equals 2 to the n power minus 3. So when you're looking for a certain pattern, they're asking us to write the first 5 terms of the sequence. So what we're going to do is, instead of having n in those positions, we're going to replace that with the values 1 through 5. So I'm going to say, okay, I got a sub a sub 1. Oh, let me erase that. So I got a sub 1, a sub 2, a sub 3, a sub 4, and then a sub 5. So what we're going to do to figure out the values in each of these sequences is, instead of having of n there, where that's our general equation, we're going to replace that with the values that we put to it. Like, so here I have 1, so anywhere where you see n in that pattern, I'm going to replace that with 1. So I'm going to say 5 times 1 minus 1, and that ends up equaling 4. Same thing goes for 2, so it's 5 times 2 minus 1, so this equals 9. 5 times 3 minus 1, which is equals 14. 5 times 4 minus 1, which equals 19. And then 5 times 5 minus 1, which equals 24. So the first 5 terms in this sequence is 4, 9, 14, 19, and 24. Same thing goes for B. So if like I have f of 1, f of 2, f of 3, f of 4, and then f of 5. So what I want to do is I get to replace n with those values. So I'm going to say 2 to the first power minus 3. I got 2 to the second power minus 3. 2 to the third power minus 3. 2 to the fourth power minus 3, and then 2 to the fifth power minus 3. So I get to use order of operation to figure out what I have to do for a certain sequence. So this one here is going to give me a negative 1. This one's going to give me a value of 1. This one will give me a value of 5. F of 4 will give me 13, and f of 5 is going to give me 29. So that one's pretty straightforward. You just have to be able to follow the values of each of the pattern. Now for examples A and B, they're asking us to describe the pattern and then write the next term and write a rule for the nth term of the sequence. When they're looking for writing the nth term in the sequence, they want you to find that general equation for the pattern, like a sub n equals something. So let's look at A. I have our values that they give us in the pattern are 2, 5, 10, 17. So first thing I want to do is I want to try to figure out what the common difference is, or whatever the ratio is. So I want to find the difference between 5 and 2, which ends up being 3. This one here ends up being 5, because 10 minus 5 is 5, and then 17 minus 10 is 7, and it looks like they're increasing by 2 units. So I'm thinking that the next value here is going to be 17 plus 9, which is going to give me a 26. So that's the next term in this sequence. But what I want to do is I want to figure out what a sub n is. Okay? And right now it's easier to find it when all the values here are the same. So let's try this again. So if I subtract these two together, I get 2. I subtract these two together, I get 2. And I subtract these two together, I get 2. So what this is, this little first little difference right here, this is called like the one tier difference. And if you find yourself having a pattern of all of those are the same thing, you're going to get like a linear equation. You know, a linear equation is like the y equals mx plus b. You're going to get a line. If you find yourself the pattern is similar in this second tier, which we have in this situation, we are going to go now have a quadratic equation, the whole ax squared plus bx plus c format. So they do tell, this does tell us a little bit about the problem. So if it finds out we have a common difference of 2 in that second tier, I know that the quadratic is going to be half of that value in that first coefficient. So I can write this as 1x squared, or just x squared, or let's say I used n, so let's keep the same variable. I'll use n squared. So I know that I'm going to take whatever value of n is, and then I'm going to square it. So this one here is a sub 1, this one's a sub 2, this one's a sub 3, and this one's a sub 4. So when I look at that, so if my n is 1, 1 squared is just going to give me 1. So what do I have to do to get 2? Well, I'm going to have to add 1. Let's see if it works for the rest of them. So if a sub 2, so that means n is 2, so it means 2 squared is 4 plus 1 is 5. If it's 3, 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. So it works. So my general equation for this particular sequence is a sub n equals n squared plus 1. If I look at b, I notice it's like -8, -4, -8, -12, -16, -20. I already identified that I can, it looks like these ones, the difference is going to be a -4, a -4, a -4, a -4. So I have myself a one tier difference that are going to be all the same, which is going to be a -4. So when I get to write my equation, I go a sub n equals, looks like I'll just take -4 times it by n. So if n is 1, -4 times 1 gives me -4. If n is 2, -4 times 2 gives me a -8, and so on and so forth. So the next pattern in this sequence, so this is a sub 1, this is 2, this is 3, this is 4, this is 5. So if I find looking for a sub 6 in this case, it's going to be a -24. The next progression in this lesson is on series. And like I kind of touched it in the beginning, series is you take the terms of a sequence and you add them together. And then what is used is what is called sigma notation. This little interesting, looks like an E symbol. It's called sigma notation. And sigma notation kind of shows us what we're going to do in order to solve for each of our series. This bottom value here where it says I equals 1. I equals 1 tells us where we're going to start with our series, like S of 1 is where we're going to start. And then this 4 over here tells us where we're going to stop. And then this 2i is what we're going to multiply by in the sequence. That's the pattern in the sequence. So if we start off with I equals 1, so 2 times 1 is 2, which we get here, and then we continue with 2. So then I equals 2. 2 times 2 is 4, which is there. And then we have 2 times 3, which is 6, and then 2 times 4, which is 8. So now that I've gotten to 4, I am finished with this particular series, so then I get to add them together. So it's like 2 plus 4 plus 6 plus 8. So this series would give me a value of 20. And that is what is called a finite series because it has a specific stopping point. This one here is an infinite series because it goes on and on to infinity. So it says I sub 1, that means it starts off with 1, and then it goes on to infinity. So as long as it keeps increasing, the actual sum will just be to infinity. So, excuse me. So here, they want us to write a series using the sigma notation. So I'm going to have it like looking like this. And then I'm going to approach it with I equals 1. And as you notice here, it has a certain stopping point. It stops at a value of 729. I don't know exactly where that stopping point is without knowing the pattern, but I'll take a look. So if we identify, we have 1, 8, 27, 64. There's a few numbers in between that, and then it ends with 729. So I I I see this as looks like they're all like cubic values. So I'm gonna give this a try and put it like I cubed, and I don't know where it stops at because let's say if 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, and 4 cubed is 64. So at least that part of the pattern we've got correct. So now what I need to find out is what value of I cubed I need to get 729. And that one would be 9. So that means that this stops at a value of 9. So my equation written in sigma notation is going to be I equals 1 to the I cubed power, and we're going to go 9 units. For B, there is no stopping point. It just says dot, dot, dot. So it's going to keep on going. So what I do is I know that this is going to go to infinity. I'm going to say this is I equals 1. And I look here, I see I have 1 plus 1/2 plus 1/4 plus 1/8. So when I'm looking at this pattern, it seems like 1 in the numerator is a common thread. So I'm going to say 1 over something. And then I need to get something that's going to give me 1, and then 2, 4, 6. Looks like these are cubic values. So I can say like, I'll put like 2 to the I minus 1 power. So if I have 1, I got 1 minus 1, which gives me 0. 2 to the 0 power is going to give me 1. So 1 divided by 1 is 1. So that checks out. And when I is 2, 2 minus 1 is 1. So 2 to the first power will just give me 2. 1 divided by 2 is the 1/2. 3 minus 1 is 2. Gives me 4. Divide that out. It works out. So this is where the equation for this one in sigma notation. A lot of it is being able to discover the pattern. And you can use that by doing common differences or just by kind of eyeballing which one, what you kind of see. For the most part, it's a lot of guess and check. So last thing we have is we're going to use the sigma notation formula to find the sum. So from here, I have 8I, and this one's going to be, it starts off with 1 and it ends with 5. So I can say that this is going to be 8 times 1, which is 8, plus 8 times 2, which is 16, plus 8 times 3, which is 24, plus 8 times 3, which is, I already said 8 times 4, which is 32, plus 8 times 5, which is 40. And so I stop because it's at 5, and then I add those together, it's going to be 120. So that's the sum of this series. If I look at B, if I have, this starts off at 3 and it needs to end at 7. So I go 3 squared minus 1 is going to give me 8, plus 4 squared minus 1, which is going to give me 15, plus 5 squared minus 1 is 24, plus 6 squared minus 1, which is 35, plus 7 squared minus 1, which is 48. So now you got the 7, I stop, add those together, I get 130. For C, you notice that I have I equals 1, but I have no I here in the pattern, and it goes up to 134. So if you ever find yourself with a value that has no pattern of I in there, you just write it as the value of the number on top. So this one's going to be 134. And my last one, I have n equals 1 to the n, 6 units. So this one's just going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6. Add these together, I get 21. And that is being able to define and use sequences in series. Hope this helps. Until next time.